Thank you. So, very good afternoon. So at the outset, I thank the HPC Council because this is the first presence of mine here. So I'm really privileged to be here. So I think as we are gathering back, and before we embark on next 20 minutes on probably a different flavor and perspective of how what I mean is essentially the enterprise outlook. So how exactly the business and enterprise outlook probably would like to embrace the advances, whether it is with respect to the machine learning, deep learning, AI, or for that matter, the high performance computing. So interestingly, the industry would like to conceal the difficulty or the tougher aspects, and they would like to see or want a good proposition to be put forth before them that makes things look simpler and should probably talk the business language, right? So whatever you're offering, finally, what is it resulting that into the kind of business insight? So maybe let me see how much I would succeed in aligning with the conference theme and probably trying to share some of these experiences and putting forth things. So while going on, even before getting to the first slide, what do you think in our day-to-day activity, where does performance meet learning or vice versa? Let me repeat. Where you think the learning, whatever the learning we have been continuously embarking upon over these many years, where does that meet the performance or HPC? And I'm saying even vice versa. So the learning leads to performance, a performance leads to learning. So what you think are the day-to-day mundane instances in which we think we are depending upon the natural computing machine, the brain's high performance? Any examples, any illustrations? Pardon? Okay, so not Google Map you're talking about? Sure, Google Maps. I'm talking about. Okay. Yeah, maybe I think I'll take the clue from there. The cue is that, interestingly, we perform the natural task of driving. So when you're driving, so instantaneously you apply the brake. And that decision perhaps takes at least about 100,000 data points for you to make the decision. Because we have a lot of internal threads spawned, we are thinking, and naturally we are actually with respect to the automobile environment. And finally, in the corner of eye, we glance at some object is rushing towards the car, or from the rear view mirror, you have seen that the other car seems to be have slightly moved in, and suddenly you have applied the brake. Fantastic. So there's one sense of learning there, and we applied a brake. And typically, what do we call that as in the learning, what do you call lingo? And I'm just trying to see what other daily scenarios do we broadly apply our learning. Almost all our daily activities. Like for example, here, I would say when we are talking, you're assimilating, right? So there is some discussion, there is some input, and the brain is invariably processing that, and you're recognizing, hey, something is being spoken, and that is some language, that is some topic, discussion. So all this broadly, I would label it as the classification / clustering. So we typically try to classify or cluster most of the times. What else do we do? Many a time, we also predict, we also forecast, right? I think most of our favorite game would be the stocks and the stock market. So we are investing. So you say that, hey, I predict tomorrow it goes up, this script goes up, that script goes up. So we try to predict or forecast a lot. The forecast will happen not only stocks, but how would be the weather, who will be the winner of so and so match, so whatnot. So the second favorite activity we indulge with respect to learning would be on forecasting. Besides these two, we also invariably do, probably we may not solve the linear program, genetic algorithm, or quadratic program, but we do optimize. Many a time, right? Even from leaving from X to Y destination, immediately we optimize in what way, what time should I start, whether traffic builds or not. So what route should I take, what mode of conveyance should be good. So we take a lot of constraints into our mind and solve a kind of optimization and solve it. So that is what typically I try to quickly recap. So when we talk about learning, whether it is machine learning, deep learning, or so-called AI, we broadly try to fit the class of problems into the broader lengths. So can any of you think anything other than this we do in our day-to-day life? In fact, even here, the last three, I can just actually put it in single umbrella of forecast, optimize, classify, cluster. At least for the discussion purpose, I guess, so we can say this is what broadly we indulge, no more, no less. Pardon? Yeah, but the recommendation would be what? You either recommend a forecasted number. If I come to you and ask, hey, what should I do with my $1,000? And you're recommending that, hey, you invest in this so that you make profit optimization, or it goes up to 2,000 forecast. Right? So I'm saying broadly the algorithmic mapping I would like to do would be to one of these problems. And why I took so much time to introduce this is that even this language is not a business wrapper. So the business wrapper wants even one more layer on top of this. And they would like to understand, hey, my current business problem is that I want to optimize my procurement. I want to optimize my investment or lower my investment. Now, hell with you guys. So you do whatever you want, whether underlying, you want to use parallel computing, or distributed computing, the cloud, the physical machines, Spark ML, deep learning, I don't care. Hence, in fact, it is a kind of continuation of, thanks to Ryan, that he introduced the services and microservices. And in what way we try to put the amenable wrappers around this complex technology, complex computing, and then try to offer that in easily digestible or easily consumable format to the business users or the end owners of these technologies. In fact, I think a couple of things yesterday from Chris' discussion, if you recall, that there is no infinite pool of money, and therefore any of these new technologies are going to actually reach acme and probably stay for some time and may taper off. The very reason is that how much we can make the business impact with respect to these layers. So that is where I thought I would take your attention to, with, of course, due courtesy to all the machine learning, all the performance computing, which is very much inherently, innately required for us to achieve that success. Another very interesting aspect when we talk about analytics lifecycle is where exactly are we spending time? When I say we especially, the category of the data science groups, the data scientists, and various other business people. Where are they spending? And again, let me tell you, this became a very interesting and intriguing question, especially in the enterprise perspective. Why? Because that is a common question we have been facing whenever you meet customer from any vertical or any segment. He was saying, hey, get the data. And what do you do with the data? So you prepare or process the data. And what is, after processing the data, what do? You tell me what I'm supposed to do. So if you are mapping or defining some, the business insights, then of course you conduct the scientific analysis or the data analysis and come back to me with the required business insights. So if that is what is the map, interestingly, how much time are we spending on the core data sciences? And how much time are we spending in technology selection? How much time are we spending on the initial data ingestion and data preparation part? So it is important for us to actually look at these multiple perspectives and then try to, what I would say is, modularize / decouple things. In fact, again, that is where I want to take this august audience attention, that when we look at any problem as a whole, it will certainly be complex, right? Like I missed the first discussion today, though I wanted to. But take simple example, the Uber, and assuming they are having, say, 100,000 requests a day. So complex. But now when you modularize that, when you actually drill down to the geolocation mapping, and then how many you think will be happening within this 1 square mile area? Because I'm sure that is where probably he would be offering the service, right? It's not that you make a request from here and it's not going to fall in the lot which is residing in San Francisco's surroundings. So the whole number of requests, when you have actually accumulated, no doubt they are 100,000, 200,000, 500,000. But the moment they got drilled down at various locations where the actual physical service is being offered, so that is falling in within a very small circumference with smaller quantity. Now I'm sure we can extrapolate the same example to the billion or 2 billion queries hitting Google servers. 2 billion, large number. But that 2 billion getting drilled down, getting mapped down to various categories, various locations, various situations, make that thing amenable. That's the point I'm trying to drive here. So it's scary when you look at the big number, but the moment we have put the right filters and right level of drill down, it is indeed making the problem tractable, making the problem resolution very much under control. Now the interesting part would be when we try to map those filters, or probably I think that is where again I go back to Ray on that. The service wrapper you want to put for the different drill downs would become critical. Even yesterday, I think that's what I was asking our good group, the Legion group, when they were talking about. So the tasking, subtasking seems to be a very, very critical requirement for me, which makes the enterprise life easier if we can give a kind of automation or if we can give a kind of a solution to that problem. Then that becomes an interesting decoupled, tractable solution offering. Okay, and this is again just a broader enterprise perspective, because oftentimes the question we come across would be, hey, can you give me a data platform solution that can ingest all this data? And I'm sure with these devices, with this IoTization, and with the ability to capture a lot of data, definitely that is one big problem each organization or enterprise is facing. So where do I keep this data? At what frequency or what interval should I capture the data? And then comes the big question, what should I do with the data? And so these are only few indicative points that when an organization wants to take the holistic picture, they have a lot of data points that get generated, and then we map various technologies, what we have been talking about last 2 days, onto these archives and these data generation points to create those systems. But after that, in fact, the next 2 slides are the crux of the discussion, that what is it that you want to do that, and where you want to put your emphasis or apply the emphasis on the decoupling or modularization perspective of analytics lifecycle. So that is where maybe we need to begin our exercise with the data ingestion, no doubt, because that is going to be creating the basis or the foundation for all our exercises. And once we have the ingestion in place, and that is where we make the decisions based out of our discussions. So should I use an MPI interface or RDMA? So whatever the tools, technologies, methodologies we discussed, they get mapped at base level on the data platform. But what I'm trying to say is that is not end by its own. And again, that is where probably I think more cohesion seems to be required to bring that end-to-end perspective that, okay, having created a data ingestion platform, what next? That's when we are saying, hey, the ingestion needs to get mapped with the specific business problem description. So is it their fleet management? Is it their procurement management? Is it their device service schedules? Is it the proactive maintenance? Is it the supply chain stocking, lean maintenance? You can reload, I think, hundreds of numbers, depends upon the verticals all of us work, depends upon the domains we work, depends upon the organizations we work. So they all actually come as various sets of business problems. And these problems invariably call for the specific data mapping. So that is the beauty, right? So the underlying archive has all the raw data, and this raw data is getting fine-tuned or fine-grained into smaller data lakes for the specific business problem we address. And again, at the enterprise outlook, so these would be the innumerable number of services, I would say, or I borrow the term from Ray, and that microservices. So they are trying to understand, on one side, the procurement optimization, the other side, the fleet management, the third side, the analysis, forecasting, performance, whatnot. Then move on that, yes, when we are talking about this machine learning, deep learning, that algorithm selection, algorithm recommendations play a vital role, which in turn call for a lot of bandwidth of the specialized engineers, programmers, data science engineers to create these models, tune the models, and then interesting part again today, which you don't find, and calls for again this kind of community's intervention on how easily will you make this machine learning, deep learning consumable? How easily can you deploy them for the real world consumption? And again, I recall yesterday's Chris words that you spend a lot of time in building a model, but how often do you need to rebuild the model? Because the model is built and that is ready to score, right? The weather forecast model has been built, sophisticated model. And is it good enough for us to predict the temperatures, the rain, the weather situation across all the geographies, all the locations, every day, every evening, every moment? So what is the frequency, or how often do you need to redeploy or rebuild, retune the model? So that is where a little bit of attention and emphasis is taken to you on the model monitoring part and model deployment. And very important, last but not least, is the the business insights and the visualization. Today again, most of the tools which you take today, where do they stop? They stop with showing few sets of plots, few sets of graphs, and stop there. But what does that graph mean? It needs to get translated to an actionable insight. So that means you have that, hey, the forecast says it is going to be a sub-zero tomorrow. So please advise me, what should I do? So do you need to take your apparel different, or you need to carry something else? So these are the actionable insights that are to be translated, where for your information, actually so my team is trying to spend more time in creating those business insight wrappers on top of the additional information we have. So I'm further drilling down on the complete analytics lifecycle, where special attention is required on the model lifecycle itself, because the model monitoring is a critical or key thing for us to adopt. Hence, we need to look at starting from the model deployment, then start monitoring in real time while we are scoring, and that scoring requires various stages or states to be monitored, such as how the input and output is varying, how the types of data which is flowing inside the system, outside the system. That is where I have just given few cues, the heuristics to watch for while we build model, deploy model, and monitoring the models. Is the data suddenly transitioning from one level to another level? Or do you see a gradual change? Or do you find few transitional states? Or are there few outliers you have? And once we have actually spent some time, again, this is where you need the high performance system, because the systems need to capture various business use cases, the corresponding models, and the models are actually scaling on both sides, the X and Y. So you have various models, model 1.1, 2.1, 3.1, and 0.1. And there is versioning that 1.1, 1.2, 1.m. So finally, you're tracking an M by N model matrix itself, and each model has hundreds and thousands of data points and algorithm variables, and imagine the complexity which we need to handle with so-called the tractable tools we have, like Spark, ML, Storm, whatever the things we're going to label them or name them. Okay, and what do we do? So I think I'm just taking last 2 minutes just to say that, okay, internally at least with the team, we try to put that decoupling around the system, and we try to bring for the enterprise easy consumption that, hey guys, you need to put, because you know that there's a lot of time going in initial data ingestion, and various teams need to collaborate, and they finally need to give you the insight. How about bringing that together on a kind of loosely coupled platform that takes the generalization to some level and specialization from that level? So we are making it actually in a hybrid approach and taking the system, which enables various teams and systems, because I think that's where, again, the previous speaker was saying, right? So we have an infrastructure team, we have a data science team, we have a database team. Yeah, these guys physically, manually call for a lot of time to collaborate and cooperate. So that is where this kind of platform should help us try to reduce the cycles from the initial business decision problem definition to the data ingestion to finally get your data insights out. So I think this I will skip for want of time, because this is typically the request flow goes through various systems. And again, courtesy, the performance systems like Spark and the analytics systems will come over as an underlying wrapper. So what I'm saying is they need to be subsumed, is my point. So the importance is there, but at the enterprise level, business level, the emphasis goes down, but we need to handle that at the same time. So taking the attention here, that where we have spent some energy and importance is that how to make the deployments easier for the people. So because today the machine learning deployment is very hard. So on your machine, write your R code, Python code, and imagine that kind of code again with scaling with a lot of data is going with much larger clusters. So taking that to the deployment, scoring, and real-time enterprise deployment is where the lot of challenges we face today, and at least we are attempting to iron that out to some extent possible. So what is that finally take home are the best practices we would like to take home is that begin with data ingestion and have several device connectors because we have a diversified data formats, and then do the data prep part of it with a specialized or another decoupled system, then prepare the ontologies and schemas, then of course the tuning, and finally, like so, you have the modeling like without ease of deployment and monitoring are short-lived. Therefore, focus on creating models that have good deployment and ease of deployment. And of course, the business insights and wrappers are very, very essential. So I stop here. Maybe I take a few questions, or I hope we have at least some perspective on what probably the machine learning, deep learning AI at enterprise level can go with the underlying HPC base.
So if I just understand this, this is a licensable product that your company is offering.
That's right.
Any part of it is open source?
In fact, the in underlying wrappers what we have taken are where we are heavily relying upon are the Spark ML and Scala libraries for the machine learning libraries. But then the remaining, the interface is the custom built platform engine. But internally it is actually using several microservice architecture because we would like to cater to various organizations and various verticals.